We start now miscellaneous exercise 7. First question, integral of 1 upon x minus x cube. So here first step is obviously you take x common. So x into 1 minus x square. Now this is quadratic and you can factorize very easily. So here x as it is, 1 minus x as it is, 1 plus here. Factors of 1 minus x square. Now what is this? Product of linear factors in the denominator. Can you recall which method should be used? Yes, partial fraction method. So here the next step is a upon one factor plus b upon another factor plus c upon third factor. Get a, b, c and put here values of a, b, c. How will compare? Comparing numerators, all these things. This is one way. Now here alternatively you can do like this. This you can complete. I'll show some another way which is indirectly partial fraction method, but it is easier than this one. See here you have 1 upon x into 1 minus x square. Right? That's what we have. Now what we do, I'll try to set this one in the numerator. So 1 is there, so I'll write minus x square plus x square. What I did, adding and subtracting x square. X into 1 minus x square as it is. In integration always we try to set that this lower expression into denominator expression into numerator. Okay. Now do individual division. This upon this, that's just 1 upon x plus this upon this. If I write this upon this here, if I just write this much upon this, then 1x will get cancelled. So you are just left with x upon 1 minus x squared, the whole dx. Now you must have realized both have standard forms. This is 1 upon x, log of mod of x. This is linear upon quadratic. What's the derivative of this quadratic? Minus 2x. So set minus 2 there. So I'll just split into two integrals here. Multiplying and dividing by minus 2. So minus 2x upon 1 minus x squared dx. Okay, now this is equals to, this is log of mod of x minus 1 by 2. You know that this is f dash and this is f dash upon f, log of mod of denominator expression. You know this. There is a standard formula, f dash upon f. What's the integral of f dash upon f? We know this. Integral of f dash upon f is log of mod of denominator expression plus c. Okay, now if you want you can do one more step. You can use the property of the log function and simplify further. Take 2 here, otherwise you can keep this as the final answer. This is indefinite integral, so plus c is there. But still if you want to do one more step, you can write like this here. Take 1 by 2 as LCM here. So what I'll get here, 2 into log of mod of x minus log of 1 minus x squared with modulus plus c. Now 2 will go in power here, and then log a minus log b. So here half as it is, this will be in the power, which is x squared upon 1 minus x squared plus c. This the required integral here. Fine. Okay. Next question. That's very standard integral. If you recall the points to remember, you have square root expression in the denominator. So what we do? The easiest way is you take the conjugate. So here root of x plus a minus root of x plus b upon, if I take conjugate here, this is free from the square root. What we did, multiplying and dividing by conjugate of the denominator expression. What's the conjugate of the denominator expression? Same expression with opposite sign. So this root will goes away here in the denominator. X will get cancelled. This is b minus a constant. I'll keep it outside. This one as it is right now, raised to 1 by 2. Your x plus b raised to 1 by 2. You know, inside the bracket both are linear functions. So you can imagine that as x and you can integrate it. This is like x, this is like x. Both are linear functions. So 1 upon b minus a. Your x plus a raised to 3 by 2. So here upon 3 by 2 minus this is x plus b raised to 3 by 2 upon 3 by 2 upon the coefficient of x which is 1 upon the coefficient of x which is 1 plus c. You can take 2 by 3 outside here. 2 by 3 b minus a. Here this is x plus a raised to 3 by 2 minus x plus b raised to 3 by 2 plus c. This is the required integral. Question number 3. Here one way to do this question is as it is given, that substitution, put x is equal to a by t. This is one. The another way is, if you are interested, you can try trigonometric substitution. Put x equals to here, a is there, so like here also here we need to put a, and here trigonometric I'll put sine square theta. So what is dx? Dx equals to a as it is. By chain rule, this is twice sine theta into cos theta into d theta. This is a substitution. This is one way to handle this by trigonometric substitution. The another way is this. I'll do this way, you can try this way. You will see that very easily you can get the answer. Okay, this is indirectly reciprocal, but here a is there, that's why we have chosen a here. Differentiation, dx equals to a being constant as it is, derivative of 1 by t is minus 1 by t square dt, you know. Now let's come to integral here. A equals to, what is dx? That is minus a by t square. Here we have dt. What is x? A by t into, here a as it is, this is a square by t minus this is a square by t square. Okay, now the question is just a simplification, remember. Okay, so how will simplify this? Here this a will get cancelled, one t will get cancelled. I'll keep minus sign outside here. Let me keep this minus outside. 1 upon t as it is. 1 t will get cancelled with this. Here I'll take one more a outside. Actually you are taking a square, but it becomes a. And I'm taking t square as LCM. So what I'll get inside this? T minus 1. You can just check. And that t square will come out from the root here. So it becomes just here by t dt. So now that again that t will get cancelled. I'll keep 1 by a outside. You are left with just root expression. I'll take into the numerator. So minus 1 by 2 dt. Now this is just a linear expression. So you can imagine that as x. So t minus 1 raised to minus 1 by 2 plus 1. That is just 1 by 2 upon 1 by 2 plus c upon the coefficient of t, which is just 1. So here now this is minus 2 by a. What is t? T, you know, it is nothing but, go back to substitution, it is a by x. So a by x minus 1 raised to 1 by 2. So minus 2 by a, your raised to 1 by 2 means inside the square root, a minus x upon x plus c integral. You can try by this way also. I'm sure you can do it. Okay. Now let's do the next question here. Question number 4, fourth one. We had earlier such question. If you just recall, here I is equal to integral 1 upon x square into x raised to 4 plus 1 raised to 3 by 4 dx. You just recall question number 9 of exercise 7.10. Just have a look on that, you will realize what we do in such questions. We take highest power common here. So this is x squared. When you take x raised to 4 outside the bracket, this 4 and this 4 will go away, so it is just x cube. 1 plus, you are taking x raised to 4 outside from this, so it is 1 upon x raised to 4 raised to 3 by 4 dx. What I did, I have done nothing here, just taking x raised to 4 from this bracket. So here 1, this is 1 by x raised to 4. Now when you take it outside, it would be like this, raised to 4 raised to 3 by 4. 4 will goes away, so it is 3. Now here, if you just notice for a while, the derivative of this is more or less x raised to 1 upon x raised to 5 only, remember. Now put x raised to minus 4 equals to t. What's the differentiation? Minus 4 x raised to minus 5 dx equals to dt. Now this much is already there, see. This is already there here, this much. So I'll take minus 1 by 4 on the other side. So 1 upon x raised to 5 dx equals to minus 1 by 4 dt. So therefore I equals to minus 1 by 4. What is this? 1 upon here. Oh, raised to 3 by 4 is there, remember here. So this is 1 plus t raised to 3 by 4 dt. Now this can be integrated very easily. Minus 1 by 4, take this one into the numerator. So minus, this is a linear function, I'll imagine this as x. So minus 3 by 4 plus 1 upon minus 3 by 4 plus 1 plus c. Just simplify, so I'll get the answer and place the value of t. What's the value of t? X raised to minus 4. So I'll get the backside answer. Okay. Next, question number 5 here, fifth question. Integral of 1 upon x raised to 1 by 2 plus x raised to 1 by 3 dx. You have here square root as well as cube root, both, remember. Now if you have normally square root, if you remember, points to remember, if you have only square root, what you can do is you can take t square substitution. If you have only cube root, we take the t cube as a substitution. Here we have both. So to remove both, we'll take x equals to t raised to 6 as a substitution. This is very common method, remember. Okay, now we differentiate it. So dx equals to 6 into t raised to 5 dt. I'll place there. So therefore I equals to, the 6 will come out here because it's a constant. Dx is placed by t raised to 5. Here dt. If I place the value here, square root and 6, so this is cube. If I place the value here, this is just t squared. 6 and square root, so you are left with cube root and 6, so you are left with square root. Okay. You can find t square common and it will get cancelled with this. So here you are left with t cube, here t plus 1 dt. Now you are at a very important place over here. How we'll do further? I hope this is clear to you. What I did, I've just taken t square common, so you will get t plus 1 and that t square will get cancelled with this, so you are left with t cube here. That's what I've written. Now I need the same expression over here. So what is to be done here? Adding and subtracting 1. T plus 1, t cube plus 1 minus 1 upon t plus 1. Why we did like this? Because this is like a cube plus b cube, and which can be integrated very easily now. T plus 1, t square minus t plus 1 upon t plus 1 minus here 1 upon t plus 1, the whole dt. So this will get cancelled. Here 6 as it is. What's the integral of this? T cube by 3 minus t square by 2 plus t minus log of mod of 1 plus t plus c. The most important step here is this one, adding and subtracting 1, remember. Then this is a cube plus b cube. A plus b, a squared minus ab plus b squared. Then individual division. Now just integration is over. You need to place the value of t. What is t? That is x raised to 1 by 6 here. And simultaneously I'll take 6 inside. So 6 by 3, which is 2. What is t cube? I suppose it would be here x raised to, you just go back to this, you'll realize what is t from this, x raised to 1 by 6, remember. So here you will get the cube is already there, raised to 1 by 2, 6 and 3, so this 3 t square. So this is x raised to, putting the value of t, x raised to 1 by 3 plus x raised to 1 by 6 minus log of 1 plus, what is t? X raised to 1 by t 6 plus c. This is the required integral of the given function here. 2 into this one minus 3. Oh sorry, here 6 will go inside. So here also you have 6. I'm sorry. That 6 will go inside this. So at both the places you will have 6. Question number 6 here. 5x upon x plus 1 into x square plus 9. Linear into quadratic. So how we'll do? By partial fraction method, you know. By partial fraction method. That's a standard way to handle such questions. Let me call this as I here. So we have, this is equals to linear factor. So I'll write a upon x plus 1. This is quadratic. So numerator should be with linear function. Linear means ax plus b, but a already used, so I'll write bx plus c upon x square plus 9 and then whole dx. Now the only important point is here, get a, b, c and place that. That's what all in all about the solution. How we'll do this? We can call this as 1. We find a, b, c and we place here. I hope this is clear to you. The numerator is not important here. For this you write constant, for this quadratic you write the linear. Now compare the numerators. What's the numerator? 5x here. Here if you take the cross multiplication, a into x square plus 9 plus x plus 1 into bx plus c. What I did? Just cross multiplication. A into x square plus 9, bx plus c into this. Okay, now we need to find a, b, c. How do we get this? You choose the value of x for which this is 0 first. So x equals to minus 1. I'll place there. So this is minus 5. Here a into minus 1 whole square, that is 10. This is 0. So we'll get the value of a. What's the value of a from this? 10 will go down, so minus 1 by 2. Fine. Now you cannot select any x for which this is 0, but to get 3 unknowns you need to get 3 values. So next I can take 0. You know such things. Anything can be chosen, remember. Why we are choosing 0? So the calculation becomes easier here. So left hand side is 0. Here a into 0 plus 9, which is 9. This is 0, so you have 1. This is 0, so you have into c. 0, 1, 0, c. Okay, but you know a. What is a? Minus 1 by 2. You take on the other side. So c will be plus 9 by 2. So you have a and c both. A is minus 1 by 2. You take on the other side, so it becomes plus this. The next, if x is, let's take, you have minus 1, 0. Now I'll take 1. Let's put x equals to 1. If I put x equals to 1 here, this is 5. A into, I'm putting 1 here, so this become 10. I'm putting 1 here, so this is 2. I'm putting 1 here, so b plus c. Now you know a and c both, so we'll get the b from this. What is a here? Minus 1 by 2. So this is minus 5. This is 2b plus 2c. What's c? 9 by 2. C. 2b, 2c. So 2 will goes away. This will be 10. 9 this side. So minus 9, 2b. So therefore b is again 1 by 2. So these are the three unknowns. I'll place there in 1. So this is a simplified form. Remember, this is not integration. This is just way of simplifying the function. What is a? Minus 1 by 2 upon linear function. So this will be, you know, log of mod of x plus 1. That's there, remember. Okay. What about b here? What's b? 1 by 2 into x. And what's c? c, you know, plus 9 by 2. So here plus 9 by 2 upon x square plus 9. Okay. So this is minus 1 by 2. This is log of mod of denominator expression, which is x plus 1. Here this is linear upon quadratic. First I'll take 1 by 2 common. So this is x plus 9 upon x square plus 9. Now we set the derivative. What's the derivative? 2x. So again multiplying dividing by 2 here. Minus 1 by 2 log of mod of x plus 1. Here 1 by 4. This is 2x upon x square plus 9 plus 18. Let me write one more step here. Multiplying and dividing by 2 here. Why we did this? Because I need 2x. Why? Because here derivative is 2x. This is linear upon quadratic form. We know it. Minus 1 by 2 log of mod of x plus 1 as it is. 1 by 4. We split into 2 integral. 2x upon x square plus 9 dx here. Then what about this? When you do individual division, this upon this and this upon this, that is plus 18 by 4, which is 9 by 2. 18 by 4, 9 by 2 upon x square plus 9 dx. You know this is a standard formula. So now final step would be, this is as it is, minus 1 by 2 log of mod of x plus 1. 1 upon 4. You know this is f dash. So log of here mod is not important because x square plus 9 is important, always positive. So modulus is not important. Now this is which standard form? You know x square plus a square. So here 9 by 2 is already there. This you know 1 upon a, so 1 by 3 tan inverse of x by a, that is x by 3 plus c. So minus 1 by 2 log of x plus 1 plus 1 by 4 log of x square plus 9 plus here 3 by 2 into tan inverse of x by 3 plus c. Integral of the given function. I understand it's a little bit lengthy but not difficult, remember. Okay. Next question. Question number 7. I equals to integral of sin x upon sin of x minus a dx. What we do? We had earlier such questions. We set this angle in the numerator, remember. This angle we are going to set here. So sin of, you know, x minus a plus a, adding and subtracting a, upon sin x minus a. We have just set the denominator angle in the numerator. Now what is this? This is like x and y, sin x plus y formula, addition formula. So sin x into cos y plus cosine x into sin y. upon sine of x minus a. Okay, then do individual division. Okay, so if you do individual division, this is just cosine a dx, this upon this, plus here sine a is constant, cos upon sine it is, it is cot of x minus a. So cosine a will come out. What's integral of 1x? Cos a as it is. Let me keep right now this one as it is. Now final step is just integration. This is a constant, remember, integration is on x. Now let's integrate. What's integral of 1x? Cos a as it is. This is linear function, so you can imagine this as x. What's the integral of cot? Log of mod of sine x minus a upon the coefficient of x, which is 1, plus c. We have this integral upon the coefficient of x, which is 1. So we have sine a here, I'm sorry, this is also my mistake. If I take sine a outside, this should be sine a, sorry. This is also sine a here. This is also sine a here. That's my mistake. Okay. Question number 8. You have e raised to 5 log x minus e raised to 4 log x upon e raised to 3 log x minus e raised to twice log x dx. Now here what we do, one of the property of the log function, 5 will go in power, 4 will go in power, 3 will go in power, 2 will go in power, and then you just recall e raised to log x, your base nothing is e, is always x. So once this will go in power, this is x raised to 5, this is x raised to 4, this is x cube, and this is minus x squared. This is a simplification with the help of properties of logarithmic functions, remember. Okay, now we just simplify. What's common in numerator? X raised to 4, so x minus 1. What is common here? X squared, so x minus 1. So you are just left with here, everything will get cancelled, x squared dx. And what is the integral of x squared? It is x cube by 3 plus c. Indefinite integral is there, so you have plus c here. Ninth question, cos x upon root of 4 minus sine squared. You can see here you have derivative of sine. So the easiest way is put sine x equals to t. What's the derivative of sine? Cos x dx equals to dt. So this will be just dt. And you will see that this is a square minus t square. Constant first inside the square root. So your final answer is in form of sine inverse. You can do it. Question number 10. You have sine raised to 8 minus cosine raised to 8 upon 1 minus 2 sine square into cos square. Now here obviously you need to simplify function. This is just simplification of trig function, remember. So what we do, first we simplify numerator. The first step is sine raised to 4x plus cos raised to 4 into your sine raised to 4x minus cos raised to 4x upon 1 minus 2 sine square cos square. Let me keep right now as it is. If necessary, we'll simplify. Let's continue here. If you remember 11th standard, sine raised to 4 plus cos raised to 4, always you can convert into perfect square. Sine raised to 4 plus cos raised to 4 minus 2 sine square x, let me write plus here, plus 2 sine square cos square minus 2 sine square cos square. Why I did like this? Can you just recall the 11th standard? Adding and subtracting this. Why this? Because this become a perfect square. It is 1 if you just recall. Okay. What are the factors of this? It has two factors further. Here you have sine square x minus cos square x into sine square x plus cos square x. The whole upon 1 minus 2 sine square cos square as it is, remember. Adding and subtracting this middle term, remember. Further two factor, a raised to 4 minus b raised to 4. Okay, so this is equals to, now what is this? This is sine square plus cos square, this much only, remember, the whole square. This is indirectly 1, remember. Sine square x into cos square x. This is just 1. You know, if I take minus common here, this is minus cos 2x. This is 1 upon 1 minus 2 sine square x into cos square x dx. So now that entire bracket will get cancelled. 1 minus 2 sine square cos square, that will goes away with this. I'll keep minus outside, so you are just left with cos 2x dx. What's the integral of cosine? That's nothing but, you know, sine 2x upon the coefficient of x, which is 2 plus c. That's it. So here the important part is just the simplification of this numerator, remember. 4 4, then here this is very well known standard expression. We did it number of times. These two are always equal, if you remember. So this will goes away. That's what we did indirectly, but I've shown in detail here, adding and subtracting middle term. Then sine raised to 4 minus cos raised to 4 is this much here. You know, 1 minus 2 sine square as it is. That will get cancelled with this. You take minus common, cos square minus sine square cos 2x, sine square plus cos square 1. So we have finally this much. Next question here. Question number 11. That is 1 upon cosine of x plus a into cosine of x plus b. Earlier we had even such questions in the beginning. If you just recall, you will come to know. So here you just, as I told you, question number 22 of exercise 7.3. Have a look at this question, you will realize I'll be doing more or less like that question only. 22 7.3. We need to set this angle there first. So I'll write x plus a. Variable should get cancelled, so I'll put minus x plus b. I wrote just angle. X will get cancelled. What is the extra? A minus b, which is constant. Now here you have cos function. So if I put cos function here, then what happens? If after expanding, one term will be 1 and the other term would have product of two functions. So I cannot use cos, so I'll put here sine. So what you have written in the numerator indirectly, sine a minus b. So I need to put 1 upon sine a minus b, remember here. Upon, this is as it is. Now question is here, I'll tell you why I have not placed the cos function. I'll tell you in the next step. I hope this is clear to you. What I did first, I wrote these two angles here with minus sign. So x will goes away. This is a minus b. Then I've applied sine. So what is numerator? Numerator is just sine a minus b. So you must have upon 1 upon sine a minus b. So this sine a minus b, sine a minus b will get cancelled. So you did nothing. This constant as it is. Now I'll use the formula for sine function. sin x cos y minus cos x sin y minus cos x sin y upon this one as it is. Now the question in our mind is, why have we used the sine function? Why not cosine? See, if I would have used the cosine here, then cos x cos y minus sin x sin y. So both are cos functions. So when you do individual division, this is 1. But here both are sine. So sine upon cos 10, sine upon cos is 10. So you have product of two 10 functions, which is difficult to handle in integration. That's why I've used this, remember. Now very simple, like that question number 22, just do individual division, so you are almost through in the solution. This upon this, so both will get cancelled. This is 10 x plus a. This upon this upon this, which is 10. This will get cancelled. When you do this upon this, then again this will get cancelled with this. So you'll get the sine upon cos, which is 10x plus b. The whole dx. Integration of 10 is known to you, remember. What's that? If you remember integral of 10, this is linear function. So you can imagine that as x. So what is this? Log of mod of, sec of x plus a. Log of mod of sec x upon the coefficient of x, which is 1, minus log of mod of sec x plus b upon the coefficient of x, which is 1 here, plus c. And now finally you can use the property of the log function. If I use the property of the log function, 1 upon sine a minus b, here log of sec x plus a upon sec x plus b plus c. If you want, you can reduce in the cos also, then you just reciprocal of this. That's not important, but here required integral is given by this. Okay, next question. Let's go to question number 12. That's again not that much difficult. X cube upon, you have 1 minus x raised to 8 dx. So you know that this is indirectly derivative of x raised to 4, remember. So what I'll do, I cannot have x raised to 8, so I'll put raised to 4 equals to t. Now you must have realized why I chosen this as a substitution, because this become t square now. And if you differentiate these, you have 4x cubed dt. So 1 by 4 will go that side here. 1 by 4 will go that side. This is dt here. This is 1. This is root of 1 minus t square. And what is this now? Why this is 1 minus t square? Because this you can write as x raised to 4 the whole square. So this is t square. Now here 1 by 4 as it is. What is this? This is nothing but constant first. So sine inverse t plus c. This is a very well known standard formula. You know it. And now place the value of t. What's t? 1 upon 4 as it is. That's nothing but the sine inverse x raised to 4 plus c. Just putting the value of t here. Question number 13 here. Integral of e raised to x upon 1 plus e raised to x into 2 plus e raised to x. If you remember points to remember, whenever your log x or exponential, if nothing can be done, put that tech as a t. So e raised to x equals to t. E raised to x dx equals to t. Differentiation. So I equals to, this become dt here. What is this? This is nothing but 1 plus t into 2 plus t. Now this is a product of two linear factors. So you can do by partial fraction method. But here linear factors are so simple. Just you can put the minus sign between these two, you will get exactly same thing. We did it directly, remember, because here factors are so simple. Do the cross multiplication, you will get 1 only. If you do cross multiplication, 2 plus t minus 1 minus t, this will get cancelled, 2 minus 1 1, right? Because your product of linear factors were very simple, remember. Now what's integral of this? Log of mod of 1 plus t upon the coefficient of t1, log of mod of 2 plus t upon the coefficient of t, that's 1. And now you just take the ratio here. So by the property of the log function we have this. And what was t? It was e raised to x. So 1 plus e raised to x upon 2 plus e raised to x plus c. That's the required integral. 14 number, I equals to integral of, you have 1 upon x square plus 1 into x square plus 4. Okay. Question number 14. Here you have same powers x square. You just go back to exercise 7.5, question number 18 and example number 14. You just look at it, these two, you will realize we had these two questions earlier in the discussion. So what I'll do, consider x square equals to y. This is not substitution. You are not going to convert into dy. This is just new variable to make the partial fraction method easier. So what happens to the function here? Function will be y plus 1 into y plus 4. Now here you can just follow this method. Which method? That a and b, but I'll try to do it directly here. I'll write some constant upon y plus 1, here y plus 4. What I'll do, I'll put minus, I'll put 1 here, I'll put 1 here. See, 4 minus 1 here, y will goes away. So what is the extra there? 3. So I'll put 1 by 3 in front of this. I did it directly. I'll show it. See, do the cross multiplication, so we'll get the y plus 4. Do the cross multiplication, minus y minus 1. This will get cancelled. 4 minus 1, which is 3. Extra, you need 1 here, so I place 1 by 3. If you do it by partial fraction method, your a will be 1 by 3 here and b will be minus 1 by 3. You can just check it. So therefore now I would be, I means given integral, 1 by 3 outside, we are placing this 1 upon, what is y? X square plus 1 minus, what is y here? X square plus 4. Just to simplify the function, remember I have not converted into dy. You must see those two questions. Okay. Now you know both are standard functions. What's the integral of the first one? It is tan inverse x minus this, you can write 2 square. So your 1 upon a, that is 1 by 2 tan inverse x by a, that is x by 2 plus c. Here 1 by 3 as it is, x square plus a square, 1 upon a tan inverse x by a. So if I take 1 by 3 inside, 1 upon 3 tan inverse x minus 1 by 6 tan inverse x by 2 plus c. Okay, so we have this. Fine. Now next question here. It's question number 15. Cos cube x into e raised to log of sin x. Oh, that's too simple, you know it. So e raised to log, this 2 will get cancelled, so we'll get just sin x here. Now at this place put cos x equals to t. So this will be dt, you know it. Just putting cos x equals to t. What's the derivative of cos? Minus sine. Minus sine x dx equals to dt. This is already there, so minus sign will be there on the other side. That minus I'll keep outside. This is t cube dt. What is the integral of t cube? That is t raised to 4 upon 4 plus c. So you have minus 1 by 4. What is t? That was, you know, cos cube. So cos raised to 4 plus c. That's required integral in question number 15.